Okay, in this screencast, I want to look at proving similar triangles. We've had a look at proving congruent triangles, and there were 4 proofs for that, and there are 4 proofs for similar triangles also. So, all right, let's get into it. First proof is this, and that is if we've got a triangle, let's say along these sort of lines here, where I've got okay, that side here is 2, this side's 3, and this side's 4. And I've got another triangle over here that, let's be sort of original about it, looks like it's gone 4, 6, 8. So we would say that this is all pairs of corresponding sides here. All 3 pairs of corresponding sides are in the same ratio. You can see 2 to 4, 4 to 8, 3 to 6, scale factor of 2 from smaller to larger. So we'd say here that this is an SSS, and that all pairs of corresponding sides are in the same ratio. So 1 is all pairs of corresponding sides are in the same ratio. So if we have that situation, then what we can say is on the basis of that evidence that these 2 triangles have to be similar, and therefore their corresponding angles would have to be equal. So it's the same principle as with congruent triangles, in that if we can establish through one of these proofs, we can establish 3 things, 3 identity statements. Now with congruency it was 3 equal statements. Here it's going to be sort of same ratio, perhaps, or same angles, equal angles. We need to establish the evidence, and then we can say on the strength of that evidence that triangles in this case are similar, and previously congruent. What that means is you can then extrapolate and say, right, well, if they're similar, then the angles are equal. This side is in the same proportion, or these sides are in the same proportion as the others, etc. Right, so 1 is all pairs of corresponding sides are in the same ratio, and we're calling that SSS. Now for congruency, that was SSS, but it was all 3 pairs of corresponding equal sides. Right, test 2, or proof 2, will be this one. It'll be it'll be the equivalent of the SAS. So it'll be, okay, I've got a triangle here. It's doing something like that. I've got a triangle that's doing something like that. And what we're going to say here is that, alright, I'll give you some information about this. This angle here and this angle here are equal, and then the sides about those angles. So again, it's the sides that are around that angle. So let's say that's 2 and that's 6, and this here is 1 and that's 3. So we can say from this that you got 2 pairs of corresponding sides in the same ratio, and the included corresponding angles are equal. So that's an SAS. So let's write that out. So that's 2 pairs. You don't have to write, you do in your notes, 2 pairs of corresponding sides, but when you're doing the proofs, you don't need to write all this stuff out. You just write SAS. 2 pairs of corresponding sides in the same ratio, and the included corresponding angle angles are equal. So this is an SAS. Okay, very good. So what we've got now is proof number 2, and that is if we've got this information here, I can see that 2 angles here are equal, and I can see that the sides around that angle are in the same proportion, and they're in the corresponding sides. Then that is going to be enough to say that these 2 triangles are similar, and therefore, as on the strength of that, I'd be able to say this angle equals this one, this angle equals this one, this will be twice the size of this side, etc. Right. So what is proof 3? Proof 3 is just 3 angles. So 3 angles. If I can show that 3 angles here, 3 angles here are the same as three angles here. So I've got this sort of information going on. That angle equals that one. That angle equals that one. That angle equals that one. Now I've got, this is an AAA. Now there was no AAA in congruent triangles, but with similar triangles, yes, of course. If we can prove that three angles, in fact, we only need to prove two angles, don't we? Because if we can prove two angles, corresponding angles are equal, then by angle sum of a triangle, the third would have to be equal. But if we can show that the corresponding angles of two triangles, the corresponding angles are equal, then we have similar triangles. So this one is three corresponding angles are equal. And that's an AAA. And actually, because of what I've just said about the angle sum of a triangle, we can get away with two, finding just two pairs of corresponding angles to be equal. Okay, and the fourth proof is the right angle hypotenuse side. So if we've got this sort of information, got a right angle triangle here. Okay, there's the right angle there, and I've got a right angle triangle here. Obviously the right angles. If I've got information about the hypotenuse, maybe that's 3 and that's 9, and then one of the other pairs of sides in the same ratio. So in this case, 1 to 3. So 1 to 3 there. Then that's good enough. It's good enough because of Pythagoras. This is the hypotenuse of two right angle triangles, and another pair of corresponding sides are in the same ratio, RHS. The hypotenuse of two right angle triangles and another pair of corresponding sides, So I told you this word corresponding was going to come up. Corresponding sides are in the same ratio. And this is RHS. Now this word corresponding is so important. If this was 3 to 9, right, and then this one was 1 to 3 there, well, they're not corresponding sides, so that wouldn't work. It's because they're corresponding, that is in the corresponding position to that. Okay, so they're the four proofs that we can fall back on and use. All right, now if we do a quick example here of how this works, let me show you an e.g. All right, let's say, here, let's put down a triangle. Let's do one of these sort of fellas. Okay, as soon as I put right angles there, we're in business, because now I can start saying A, B, C, D, E. Right, now I've got to set this up just like I did with congruent triangles. Right, what can I use? Well, I've got no information about sides. I'm going to have to, I'll tell you what, I don't need, I've got enough information on angles there, but we're going to, all right, so the example here is to show that triangle ABC is similar to triangle DEC, and find the value of X. Okay, so I'm going to give you X here and 5 here, and I'm going to give you 2 here and 4 here. Okay, so that'll do. So show that ABC is similar to DEC. So how can I do that? And like with congruency, I'm going to sit back, I'm going to find out what I'm going to have a game plan first. Well, right, what I can do is I know that as soon as I've got parallel lines, I know that I've got some things to work with. I've got Z angles here. So this angle is equal to this angle. They're alternate angles. This angle here, for the same reason, is equal to this angle here. They're also alternate. And this angle and this angle are vertically opposite. So I've got three angles. I've got the AAA. So I'm now just to write that out. So this is how I'd write it out. I'd write angle ABC is equal to this angle in here, angle DEC. Doesn't matter whether I call it DEC or CED, but I've got to have E in the middle. And they're alternate. I've got to give my reasons. Next one, CDE. CDE is equal to BAC, also alternate. Now that's enough. I've got two angles. That's enough. So therefore, ABC, triangle ABC, is congruent to, now I'm going to be careful about how I write this. So the A and the D angle are in corresponding positions. So I'll pull that D. Now the B and the E in corresponding positions. So I'm going to call it triangle DEC. I've proved it through AAA. Now, as a result of that, I know the sides, corresponding sides, are in the same ratio. So therefore, I can say that the scale factor, look at that, ED to AB, I'm going to say is ED to AB, which is equal to 2 to 4. Actually, I'll go the other way around. Because my X is up there. So what I can say is that X is that in the same position as the 5? It's not, is it? So I'm going to move that 5 across to there. Okay, so you can see that the X is opposite that angle there, the O angle, as is the 5. So they're in corresponding positions, the X and the 5. So the X to the 5 will be equal to the AB to ED, the 4 to 2, so 4 over 2. So X over 5 will equal 4 over 2, so X will equal 5 times 4 is 25 times 4 over 2, which is equal to 10. So I've found my value of X, it's 10, and I've done that using the ratio of corresponding sides being in the same, so it's being equal, in proportion, the corresponding sides being in the same proportion. So X to 5, their corresponding sides, equals 4 to 2. So X is equal to 10. You can see there that the scale factor from this triangle to this triangle is 2 to 1. So these being similar in corresponding positions, corresponding sides, this side will have to be twice this side, so its value is 10. Okay, we'll leave it there. We've got some work to get on with exercise 2E, and that will be the task for Tuesday and possibly Wednesday as well. Okay, thank you.